Okay, we're supposed to have around 20 students. If I refer to outer student list, I don't know whether coordinator has updated the list or not, because basically we extract, we get the list from SMAP, something like that, based on your registration. Only coordinator can do that. So I just can browse and check the number of student for this session particularly. However, kita mulakan je lah. Okay. While waiting for the rest, kita mulakan saja. So let me start with the recording. Okay. Alright. Assalamualaikum warahmatullahi wabarakatuh and good morning. Welcome to MMEA experiment number 7. So basically MMEA stands for Makmal, Medicine, Elektrik, Asas. So where does this lab located? Basically, you can find this lab at F1 complex. So F1 is actually next to F2, and F2, for the exam hall. So the huge exam hall. So we are located next to F2 and separated by a small space of land. Okay, ada kawasan ruang tanah yang luas tu, agak luas, whereby you can find a mini tower in the middle. Okay, so we are between F2 and F. This tower is actually between F2 and F1. So it's a small complex building. Okay. Then let me share with you. Okay. Oops. Where is I started? So semua boleh nampak. So this is lead sheet of experiment number 7.
Boleh, sir.
Alright, good. Thank you for the response. By the way, alright. So make sure you are in the right lab or in the right course. So we have BEV 20901. Okay, and then we have electrical engineering lab number 2, experiment number 7. Okay, and then this is the title: design of electrical single phase 2 slot 2 pole 2S2P permanent magnet synchronous motor PMSM. Right. So the learning outcome. So at the end of this lab or at the end of the experiment, you must be able to design a single phase, okay, 2S2 pole magnet synchronous motor using JMAC designer. So this is some sort of FEA, okay, or finite element analysis, FEA, okay, finite element analysis, so-called the JMAC designer. Oops, and consists of both the, I would say, geometry editor here. Okay, geometry editor as well as the GMAC designer itself. Right. So the workflow, geometry editor and GMAC designer. Okay. And then the second learning outcome. So you must be able to analyze the flux characteristics of a single phase 2 pole 2 slot 2 pole PM SM. So at the end of the experiment, so you are going to plot out a graph that represent a flux linkage or flux characteristic between the winding or the coil, the machine coil. So in introduction to JMAC, This is a software for the development and design of electrical devices, including this particular machine. And then this is actually incorporates simulation technology, accurately analyze a wide range of physical phenomena that includes complicated geometry, okay, then various material property. We can also have a heat and structure analysis, which is located at the center of the electromagnetic fields. Okay. So being used for the development of drive motor for electric vehicle. This is actually one of the application lah. Okay. So for the software can be used in order to draw, to design, to develop, drive motor, okay, for electric vehicles. Then on the theory of the permanent magnet synchronous motor, so basically, or in short, we have PM, SM. So the keyword is synchronous and permanent magnet. All right, for any type of motor, basically we have the stator and the rotor part. Okay, the stator over here, right, and the rotor part. The most interesting part is actually this area, okay, the rotor, right? And then in general, we do have some kind of winding. So something like this, a winding, something like this, the coil, ada gegelung situ, lilitan dia. And then this winding is very common in any type of motor, especially located at the rotor part of the machine. By the way, somehow we can also replace this winding for the field excitation. So this is actually basically the the so-called field excitation, okay? FE, field excitation, that provide a DC supply. Somehow we might able to replace with permanent magnet here. Meaning, so we don't have DC, the field excitation, so we don't have the coil over here. Instead, we have the permanent magnet. Okay, this permanent magnet is represented in pink color over here, right? Yang inilah diwakili warna pink ni. So dia seketul satu. Dia ada dua unit kat situ lah. So there are two units over there located on the mounted on this top surface of the rotor. Okay, this is where the term of permanent magnet coming from. Right? So this is how it gets the name of the permanent magnet. So what about the synchronous motor? Okay, and then basically, okay, actually you can read from the sentences over there. So synchronous motor is an AC. Okay, this is an AC type. Rotation of the shaft is synchronized with the frequency of the AC supply current. Okay, so it has the ANC, the synchronous speed, right, which is kat sini is actually equal to the FE, the electrical supply frequency, right? So speed dia sama daripada RMF. RMF is actually rotating magnetic field daripada armature coil. Armature coil ni yang AC tadilah. Armature coil AC. Okay, macam mana simbol dia? Macam ni lah. AC supply. Single phase untuk contoh eksperimen yang ketujuh ni. It can be also three phase. It depend on how complex your design is. And then kalau kita boleh lukiskan dia punya karakteristik untuk speed tu so karakteristik on speed, mana saya punya cursor, okay, dia keluar kat situ. Okay, saya nak pakai rating pad ni. Rating pad ni tak berapa nak mesra dengan saya lah. So I prefer more to have using the mouse lah. Tapi tak apa. Kita gunakan trykan rating pad ni. Okay, katalah kat sini. Sini apa? Yang ini adalah time in seconds. Katalah kat sini 10 milliseconds lah. So kita tunjukkanlah how fast it respond up to the and this is speed lah. Speed ataupun RPM. RPM. Right. So this is the speed. Okay, dia punya respond to very fast, even with for 10 milliseconds up to the steady state condition at how much? 1200 RPM, for example. Right? So the RPM. So this is in terms of the time or the speed versus the time of a synchronous motor. So what about the torque speed characteristic? Ini teori lah sikit lah, teori sikit berkenaan dengan synchronous motor. Kita dah lihat tadi the definition of PM. So in terms of torque speed characteristic, so kita ada kat sini adalah induced torque. Okay, induced torque. Okay. And then kalau kita ingat lah, dia punya karakteristik tu ada garis tegak sini. So we have the vertical line over here. So kita ada top. So yang inilah tadi dia punya and synchronous speed tu. Contohnya 1200 RPM. Sorry, dekat bawah. Ini bukan NS dah. So kat sini bawah. So ini ada tadi dia punya N atau in RPM the unit. Okay. So yang ini adalah dia punya NS pada 1000 padam pada 1200 at 1200 RPM. Okay. So we have the pull out torque kat sini kan. So if you refer to the torque speed characteristic, so we have the TPU or TPO. This is a pull out torque with the rated torque over here. You can see that we are not able to control the speed of, it's not a multi-level speed of machine, type of machine. So katalah yang selalunya kita ada torque speed macam tu kan, ataupun dia akan drop untuk induction motor. For induction motor, for example, peak and then dia akan drop. But for this particular machine, so we have a vertical line over here which represents the synchronous speed of the motor. For example, at 1200 RPM. So they shoot up to pull out torque. Okay, ataupun kat sini lah in terms of speed. Okay, so in few milliseconds, so it's already get to the steady state speed up to 1200, for example, RPM. And then what is next, so has a special property of maintaining a constant. Okay, this is constant. Okay, kalau lihat kat sini dia constant. Okay, the speed also constant. Alright, constant speed. So to off load up to the full load. Maksudnya kat sini dia punya regulation. So the speed SR, the speed regulation. So this is equal to 0 because speed at 0, no load. Okay, this is speed at no load, and then this is speed at full load, maximum load, for example. And L during no load at the beginning of the rotation, and full load here over here. FL full load and L is no load is equal pada 1200. So kalau kita ada full load, okay, minus no load sama dengan no load. So this is equal to 0 lah for the speed regulation. Sebab dia sama 1200 tolak 1200 minus over to 1000 or 1200. So this is equal to 0. Useful motor application where the running speed must be accurately known and unvarying. So dia tak berubah lah. Nilai dia kita dah tetapkan. So kita fix, we know the accurate value, for example, to 1200, and then dia tak berubah. It's not, it's a fixed value. So it's a unvarying value, right? Rotating electric machine where the stator classic single phase. Okay, ini kita akan lihatlah the working principle tadi, apa dimaksudkan dengan permanent magnet, okay, rotomagnetic field, bla bla bla, down here. Okay, down here. Saya akan explain jugalah. So activity number 1, so geometry editor. So the cross sectional view and corresponding parameter of 2S to P single phase PMSM are illustrated in figure 7.1 and table 7.1 respectively. Saya padam inilah. I don't know. So now we have so much better page. of lap sheet. Okay. So kita ada part number 1 is actually the permanent magnet. So here is number 1. So the pink color over here. So this is permanent magnet. Unit number 1 and unit number 2. Second, we have shaft. Shaft kat tengah-tengah ni, the white color. Yang ini adalah tegak shaft. Kat telah dia punya center, the middle is dot here. So this is the middle of the machine or the middle of the shaft. Right? Shaft where we put our rotor lah. Okay, so shaft which hold the rotor. Okay, yang inilah rotor nombor 3. Nombor 3 is rotor warna kuning. Kemudian number 4 is the stator, the crayon color. And then armature coil. Part number 5 is the green one. So the green one is usually not part, but this is slot. Okay. So in this particular drawing, in this particular cross-sectional view, so the green one is not part, but this is a slot where we put our armature coil. Dia jadi macam compartment lah, dia jadi macam ruang, compartment where we put our, or we install our armature coil. So we do winding kat sini. Later on saya akan tunjuk lah. We do winding, kita lilit dekat mana ni, stator tools ni ataupun stator pole kat sini. Kita lilit. So bila lilit ni atas bawah ni perlukan ruang. Kita lilit. So atas, top and bottom, they need space of course, isn't it? To locate the armature coil. So that slot, that ruang, that space, that room is so called the armature coil slot, which is represented in green color. Okay. So I repeat for the, okay, dia sama kat tengah ni lah. Dia macam egg, yang putih ni air gap, ruang. Yang putih adalah air gap. Maksudnya shaft kita tak lukis dalam JMAC. Shaft kita tak lukis dalam JMAC. Yang ruang ni, the air gap ni pun kita tak lukis. If you zoom in, you will see the air gap between rotor and stator. Kita tak lukiskan yang putih-putih ni. By right, armature coil pun di ruang kan, saya sebut kan, armature coil kat sini, slot ni ada ruang, tetapi kita tetap kena lukis for us to assign a specific compartment for armature coil, right? And then how do we do the, okay, we done with the name of part, PMSM. Now we come to this term, right? We come to this term, so we have seen this term. And then we go to the 2S, 2P term. So 2S is actually slot pole or slot number. Sorry, stator pole or slot number. Stator pole is over here. So the crayon color yang gigi nombor 1. So this is gigi nombor 2. The tooth number 1 and tooth number 2, or pole number 1, pole number 2. The stator pole, we write it over here. Okay, like this slot, 2 slot. Right? If 3 lah. If 4, let's say kita ada another slot over here. Color dia sama lah kat sini. Let's see. Let's say saya sketch macam ni. Let's say we sketch like this. So the 4th tools, ini sama color the crayon kat sini kan. So this is, now we change. We have 1, 2, 3 and 4 stator pole or slot number. So now become 4S. Right. This is for example lah. Let's say we have 4 pole over here, stator pole. So we should write 4S as the name of the machine. So how we give the name lah of the machine. So and then the 2 pole is sorry, this is the slot number, and then this is, okay. Move to the next column, which is rotor pole. Right. So we have done with this. So now we have rotor pole. So refer to here, the second column over here. Sorry, the second row. So rotor pole numbers. So we have 2 pole, sama lah. Tengok pada rotor yang ini, yang kuning ni lah kan. Rotor number 1 and rotor number. Setelah kita ada 4 kat situ lagi kan. So we have over here, okay. Extruding part kat sini, extruded part over here. So we have number 3 and we have number 4. By right, we should change the code over here to off. Sorry, undo. So we have 4P over here. All right, and then we have done with that code, and then outer radius. We go to the next parameter. So outer radius of stator. So all the meter in mm. So we have 45. So this represents the outer radius of stator. This is stator, the crayon color, right? And then this is the middle of the machine, the center of the machine. So the outer radius, outer, go to the maximum here. Okay. So the maximum diameter of or radius of motor. Okay. So this is the outer radius of stator. Here, the outer radius of stator, 45. So what is active axial length? So this is the stack length. Let's say we extrude. Kita extend, we extend. So let's say we extend the design to 3D. 3D kan? Di 3D dia ada the depth ke dalam. Dia ke dalam. Tapi kita buat macam ni. So dia jadi 3D over there. So the 3D drawing. And then the stack length. This is the distance, the length, the depth. So this is how much just now? 25, they say. So 25, okay, 25. All right, 25 mm. So this is called so-called the stack length or the active axial length. This item number 4. Right. So a gap length is a very small one, 0.5 is actually in between the rotor or permanent magnet and the stator tooth over here. Okay, here this is the air gap. All right, air gap of the rotor and the stator. Okay, and then what else? We have the rotor pole length right over here. So the rotor pole length over here, right? And then what else? Also we have the outer radius of rotor. Pole length tu yang ini, this is only. So this radius, of course, you must take from the center. Okay, for example, so this is the different lah. So we have 10 for the rotor pole length. Okay, the rotor pole length over here. Then we have a outer radius of rotor. So we should start from here. So outer di paling maksimum keluar ujung. This is the radius. And then the shaft radius, the white color one. So here is the shaft. So what is the radius of the shaft? So you may refer again to the table. So this gives 5 mm. So this is equal to the inner radius of rotor. The shaft radius over here, zoom in. So this is 5 for example. So the shaft radius, the white color one, is equal, sama dengan radius untuk and then what next? We have the permanent magnet width. Okay, the permanent magnet width is actually inilah. Right. Oops. Lama. Not shift but zoom. Yang inilah the width. Permanent magnet width. Okay. Dia punya permukaan dia lebar nanti sama dengan stator. Width yang atas bawah ni, yang vertical kat sini. So this is equal to the rotor punya width. Rotor tooth width ataupun rotor pole width. So sini pun sama dengan stator. So these three are equal. Stator, the width, stator tooth width, and then the PM width, rotor width. Okay, lebar dia samalah tiga-tiga ni. Berapa nilai dia? So refer again pada, maksudnya kalau dia beri, if the table give only one value, add stator for example, so you by right you must know lah, the rest of the width is also same for the rotor and also for the permanent magnet. Okay, here the following item over here. So stator tooth width if given by 5 mm. 5 mm. Over there. So this means this is 5. This is 5. mm, this is 5 mm. So what's next? The parameter, number of turn per phase is 10, 10. So nanti saya akan tunjuk in detail number of turn. So this is n equal to 10. So I will show you in detail, not in detail, but I will show you on how to do the coil or how to do the illustration of the coil. The outer pitch is 5 mm. Dia punya yoke kat sini. Okay, this is the yoke lah. This is yoke ataupun outer pitch of stator. In this particular example, we have 5 mm. Di mana tadi? This one, outer pitch. Speed RPM is 1000 and 100. 1000. Okay, alright. Kita tutup dulu. Bukalah yang baru. Itulah kerja kita lah. Buka tutup dapat yang baru sampailah Abang Jamil hidup semula. Okay, now you have the clean sheet. Okay, now back to the number of turn. Okay. Right, so later on I will show you how to do. Essentially, in the same time, I am showing you or demonstrating the setting of this one. Okay, the setting of this one, figure 10.7. So this is what? This is the direction of current. And so the pembanding magnet lah. Current means carried by armature coil. Carried by armature coil, carried by armature coil, armature coil, armature coil. Termasuk saya akan tunjukkan demo which I'm going to show you is actually coming from figure 7.10. Right. Alright, back to our cross-sectional view over here. So just imagine, boleh tak kita gunakan yang ni? So much better, isn't it? Okay, we do like this lah. We do at here. So this is the coil. Okay, positive into the pitch. So this is out of pitch. Okay, so we have a positive and also negative. So let's say we have coil copper conductor, right? So we have C1 conductor kita yang nombor 1, yang pertama. So yang ini dia masuk dalam pitch, masuk dia akan pergi ke bawah lah. Okay, so ni akan keluar. Bottom dia akan keluar out of pitch. So kita buat lilitan yang pertama. Mana tadi? Kat sini. Katalah kat sini keluar, pergi ke bawah ni. And then dia keluar kat bawah, kita bukan gulung, lilit. Kita lilit dia. Lilit. Turn number 2. And then turn number 3. Okay, that's why we need this green area. This is space. Space again untuk kita beri ruang kepada lilitan kat sini. So 1, 2, 3 and then we have the fourth turn up to taklah sampai dekat stator ni, dia berkumpul kat sini lah. It can be overlap from one to another, and of course you must have the lamination. Sampailah n dalam contoh ni n 10 je, kita letak 10 je. Simple as simple as 10 for the number of turn. So masuk dekat atas ni, masuk dekat bawah dia lah. So dia mula daripada atas, we start from the top of the stator tools and then go downward, okay, behind the stator tools or the stator pole, and then it move outward from the bottom ke atas. Okay. Dan bila dia keluar kat situ, let's say dia keluar yang turn number 10, so dia keluar all the way, dia tak bersambung lah, dia jump katalah pergi ke second stator pole. Yang ini tadi kita assign dia positif, into page, cross. Alright, saya lukiskan, I redraw again. So we have dot, then we have the coil number 2 over here. Okay, dia akan pergi ke bawah behind the tools and then make the turn number 1, turn number 2, turn number 3, turn number 4, turn number 5, turn number 6, 8, 9, 10. Samalah yang ni, and equal to 10. Okay, so dia selesai, pergi ke bawah, keluar sini. So this is coil number coil number 2. So somehow we actually integrating or we are connecting between C1 and C2. So kalau kita boleh scan dia punya electrical, a simple electrical circuit over here. So it looks like this. Okay. FEM coil number 1. So in detail, coil number 1 and then 1 and katalah gunakan pen ni lah. Saya lukiskan pen. Okay. FEM coil number 2. Okay. All right, and then we give a single AC single field over here. Okay, 240 volt for example, and then this current will energize our coil number 1. So they akan energize coil number 2. So that induce from here, so from current will induce rotating magnetic field RMF. Kalau remember masa kita darjah 3 silap, darjah 3 kita ada conductor over there, and then according to right hand grip rules, so kat sini kita akan induce magnetic rotating magnetic field over here. Okay, magnetic field. Yang dotted line is actually magnetic field. So ini adalah direction of I ataupun current. So inward. So yang ini adalah outward lah, from bottom to top. So same goes to our solenoid. So we have our solenoid over here lah kan. Our solenoid over here. Okay. So kita ada I masuk. So sini kita I keluar. So sini akan induce magnetic field. Arrow dia kat macam ni. Arrow dia like this. This arrow this direction. This direction downward into the solenoid, out of solenoid. Okay. So we have N. You have over here S. So this is a rotating magnetic field, blah 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 blah. So daripada these rules, and also these rules, we have conductor over here, we have solenoid over here. So samalah same goes over here. Dekat sini dia akan, here we induce a RMF again, RM over here. So this is S and this is N, south and north. Okay. So permanent magnet kita tadi apa? Permanent magnet kita adalah S kat sini. Ini adalah N. So ini ada nak panah dia. So dia akan mengalir macam ni lah. So it will flow like this. This is the direction of the flux from permanent magnet. Alright. So this dua ni, okay, these two characteristic, the RMF. So it come with its own acceleration. So dia akan pecut, ada pecutan dia. Acceleration dia ada speed dia sendiri. So this RMF between rotor and stator. So they try to catch up each other. So come to the relative speed which is equal to 0. Okay. Equal to 0. That means they come to the synchronous speed from rotor and also stator. Synchronous speed for rotor and stator. Kat situ kita namakan dia synchronous speed lah ataupun synchronous mode. Okay, and then kita dah selesai lah dengan sedikit a little bit on the working instruction, not working instruction but working principle of PMSM. Okay, it means how it works lah, how it get the name of synchronous motor. Okay. So the application tu you boleh Google sendiri lah. The application of course in heavy industry for example, okay. Train drive for example, okay. Aerospace, robotic, blah blah blah, which require a high starting torque. Okay. So bila heavy duty of course lah, bila starting tu, the starting of the motor, so which heavy, they carry heavy load and require high starting torque, which is the advantage of synchronous machine. Not only, but this is the contribution of synchronous motor which able to carry high load at the starting, at the beginning of the operation. Okay, yang ini tadi, this is actually activity number 1, the geometry editor. You should sketch your design in the geometry editor. So starting from the rotor, and then we have what? So we have this is rotor, this is stator, this is armature coil, permanent magnet, and end of process before move to the JMAC editor. So it convert to JMAC editor to set the material of the permanent magnet, what type of permanent magnet you use, neodymium for example, and then the steel, so for the rotor stator, so what type of steel for example, and then armature coil, the conductor, the type of the material you can find over here later on. Okay, here, right? So the steel, Nippon type, okay, the code, conductor copper, so the neodymium or new max, blah blah blah. Okay, so this is the condition, which is another part of the JMAC designer, right? If you back to the flow chart over here, so after you complete with the material setting, then you move off to the condition. Maksudnya dia punya torque, kita nak give torque dia, and then kita nak give dia punya rotation of the rotor, blah blah blah. And then the set the circuit, nanti ada tunjuk dekat bawah. So we'll show later on how to set the circuit, ataupun boleh rujuk yang saya lukiskan tadi. It's the same thing lah. Okay, ialah. So this is the circuit implementation. The simple circuit implementation. Then what else? So we have set, mesh, and study property, and then come to the run and simulation. Okay, yang ini you all boleh tengok detail. Somehow we are lucky because we have Dr. Irfan in our session today. So he will show you how to do all the drawings, all the sketching in JMAC. Okay, it's a simple one. It's a basic one. And the detail will be shared with you later on in checkbox where I will give the link. I will give you the link to the YouTube channel. So credit again goes to Dr. Isham and as well as Dr. Irfan. They collab together in order to prepare the YouTube video on the JMAC tutorial, particularly for this type of design or this type of experiment. All right. So now I would like to hand over to Dr. Irfan. So he will show you a bit on how to start up with the JMAC or geometry editor. All right. So over to you, Dr. Irfan.
Thank you very much, Doctor. And Assalamualaikum warahmatullahi wabarakatuh. Today our session is we will have geometry editor section. We will see how we sketch the geometry of the machine. So we open the JMAC initially, and then we go to project and title, and just right click and go to geometry editor, then create geometry. So before we go to the geometry editor, we'll go to save the project first. After that, save the project by any name, exercise. Our geometry editor is now open. So in geometry editor, we'll first I sketch the rotor part, and from the experiment sheet we can see the rotor part. This table we know the parameters of the rotor. So we go first initially here, create 2D sketch, just like click here, and after that it appear here, and then right click and go to the properties, just change the name to rotor, and then change the color. That's okay. So after that, now we will draw drawing. So on the sheet we can see two poles to the rotor pole. Sorry. So we have 2 poles. So it means our total complete design circle 360 degrees. So 360 divided by 2, so it will be 180. Only we are making the 1/4 of the design, so we will divide by 2. So 180 divided by 2 will be 90 degrees. So we will, yeah. So this will be our working space only. This will be our working space, and then we will draw now. We work on this design, this part only, this coordinate only, 90 degrees. So from the sheet we can see that the outer radius of the rotor is 24. So we will draw a circle by clicking here. Just click here and then middle and draw a circle. And radius, change the radius is 24. And then we have shaft. Shaft radius is 5. So we will draw another circle, which is shaft radius is 5. Okay. All right. Now we have the rotor pole length. Rotor pole length. So rotor, we can see here rotor pole length is 10. So the outer radius is 24 minus 10 will be 14. So we will draw a circle of radius 14. So this will give us a rotor length of 14. This is the rotor length. From here to here is rotor length. So now after this, that's all. We have drawn the sketch of the rotor. Now we just trim the unwanted lines. You can see from this option, trim. You can trim the sketch. Okay, all right. Before that, we have the pole width. From the design, you can see here the pole width of 5. So it means the total pole width is 10. So we are making only half, so it will be half, so it will become 10. I mean, say after we mirror, it will become 10. Just draw a line from here and just fix this line and then make it parallel, and the distance between these two is 5. Right. After the outer radius is 24, so we just draw 24 outer radius. After that, the PM width from the table, we can see the PM width is 3.5. The permanent magnet width is 3.5. So this is 24. 24 plus 3.5 will be 27.5. So we'll just draw another circle of 27.5. Right. Again, now we'll do the pole length. So we just click the line here. We draw a line from center and draw another line. Press escape and then just right click and fix this line. And then control, select this line, parallel, and then the distance. The distance is 5 because the pole rotor length is PM length is similar with the rotor pole, so it will be 5. So now we'll delete unwanted lines here. This is delete, trim it. Again now the PM sketch is created, so we can now make the region, select the PM part, and then go to the create region. Just click here, region is created. Now similarly we will make the mirror. Just right click and just click from the mirror, copy mirror, and then click on the edge, and then it will create it. Because it's one part, so we can merge it, and our PM is created. Similarly, again we have the duplication of this one, so we will click on the circular pattern. Just click on center, and then right and click on the this region. So our angle is 180, so we'll 180, and it will be created another part. Our second magnet will be created. So we need to merge them before we. Okay, no need to merge because already these both are different. So our PM is created. Now our third part is stator. Just similarly again we go to sketch, create 2D sketch, and then right click, go to properties, and change the name, stator, and change the color. Okay. So again, you see from the parameters, the outer radius of the stator is 45. So we will draw a circle of 45 angle radius 45, and our air gap is 0.5. So the rotor inner radius, stator inner radius will be this is 27.5 plus 0.5 is the air gap. It will be 28. The stator outer inner radius is 28. Again, this one we have 2 poles, so angle will be 90, just like we did in the rotor 160 divided by 2, and we are only creating 1/4, so it will be divided by 2 again, so it will be 90. So this 90 angle we will work on this one. So again we have the stator pole now. Stator pole is similar value with the rotor, so it's also 5, and total is 10. Just right click and make parallel line, and the distance is 5. Right, and then after that we have stator outer pitch. Outer pitch means the distance from from green to outer radius. This is the stator pitch. So we will draw another circle. Just click here, and total angle, total outer radius is 45. So we have pitch is 5. So 45 minus 5 will be 40. So 40 will be our out radius of the circle. Right, now we can trim the unwanted lines. Right. Just click here, delete this one, and this one. Our stator part is created. Just now select and create a region. The region is created. After that, we will have the mirror. Copy the mirror. Just click on any edge, and then just click on the region. It will be automatically created. Then again we have a circular pattern for duplication. So just click on right click on at the center, and click on the stator part, and angle is 180. Just now we have calculated, so it is also created. So we'll make it merge them both. So now our final part is armature coil. So again we will do similar steps will follow. Create a 2D sketch. Right click, go to properties, and SC armature coils. Then we'll change the color also, and then so from here you can see that outer page for the stator and the armature coil radius is similar, so we will follow that one. And also inner stator radius is similar, so we just follow that one. Our outer patch is 40, and inner radius of the stator is 28. Right. And we will draw and the line from here, because this region is 90 degrees. There are two coils only, so that's why we have 90 degrees. And then the rotor pole is similar, so just right click, text this line, and then make parallel, and the distance is 5, similar. Now our armature paths also created, we just trim the unwanted lines. Right. Now we select the created portion and create a region. A region is created, and we just copy mirror from any mirror the image, and then we go to the radial portion, circular portion. Just click on both, and then angle is 180, and it's created. No need to merge because both are winding, so we don't merge them. So our final AC part is also created. So after that, we'll go to the JMX designer and then right click on the project title and go to geometry editor and import geometry. So now geometry is imported. So from here in JMX designer, further you can analysis. You have for your reference, you have the YouTube video, and that's all from my side. If you have any question, you can ask me.
All right, thank you very much, Dr. Irfan.
Thank you, Doctor.
All right. So as I mentioned just now, and what have been told by Dr. Irfan, you can always refer to YouTube channel, the one I share in chat box, if you miss what Dr. Irfan has demonstrated just now. Okay. So what else you can find in chat box? First is link to the JMX installer, the 2019 free download version. So you can download from there. The size of the software is about 3 GB. So make sure you have enough space in your laptop or in your desktop before you download it. And then the next item you can find is the YouTube link for the geometry editor, transition study, etc., etc. Right. Basically, there are 3 parts of YouTube channel, YouTube video for this particular experiment. And then last but not least is the attendance form lah. So you all please fill up the attendance for today's session. And then in terms of report, I believe Dr. Said Zahurul, during the first week of this semester, so I have given the briefing on how you should prepare your report and where to submit. Okay. So the cover report also you can find in outer, and some of the assessment criteria. So the assessment criteria is actually reflecting the content of the report. So you must have for the online experiments. I think we have 2 different type of assessment or 2 different type of report. So the first one is the online, what we are having right now. So you must write down the method, and then followed by the analysis, result analysis, and then what the discussion, the question, etc., etc. Okay. So the result, I think I forgot to show you the result. What should you put in your result? Let me again share with you my screen. My screen. So boleh nampak So again boleh nampak, hopefully you boleh nampak kat mana? Kat mana tadi? Conteng. Kita zoom in, kita zoom out. So Jamback Designer, okay, after you complete with the first activity, so you jump over to Jamback Designer, activity number 2. Then you here, step number 11. So plot the graph in Microsoft Excel, analyze the finding. So what type of graph? So you must choose a magnetic flux of FEM coil. Okay, figure 7.12 kat mana? Kat bawah. 7.12 is here, right? If you go to the Jamback, and then you can, after you run and after you successfully simulate the design without any error, so you can go to the result option and then click on graph, and then there is a list of graph or list of result. So torque, Lorentz force, Joule loss, hysteresis losses, current. So you must go to magnetic flux of FEM coil and show the graph. Okay. So show the graph. I will draw for you. It looks like something like this. Okay. Yeah, of course, it start with 0, right? So it start from here. So it start from 0 angle. So in the middle is something like 180 degrees. So they end up dekat one complete cycle, which is 360 degree. So this is the flux reading or the flux Weber, the flux level in Weber. So you can observe how good is the amplitude of the flux or the graph. I'm not sure, maybe 30 milli, okay, Weber for example, right? And we have a negative 30 milli over here, okay, Weber. So we have peak to peak, which is equal to 60 milli Weber. So you must have the first graph for the activity under activity number 2. Okay. So this is 2D, and then this is 3D. So extend to the model. So pergi pada to the model study kat sini, project, and then extend model to 3D. So it will show you like something like this lah, 3.7.13. So now you have extended your design from 2D to 3D, and then do all the setting. Number 2, setting number 3, 4, so up to 5. For this one, step number 2, set the symmetry boundary condition by setting all bottom face and all top face. So all top face, bottom and top. That means we have 3D. So we have this, let's say this is the front. Okay. As you rotate to the backward, you will see this back face. Okay, front and back or rear, ataupun this is in instruction, it is called top lah, this one, top face, and then this is bottom face. So in Jamback, so this is equal to back face 3D, because 3D we have front and back. Okay, so this is front. This is front, this is back. Don't get confused with the term top and front, bottom and back. So you must set the symmetry boundary for so this means this is I cross this one, I cross this is something like confusing. Okay, cross this one. So all must be top. Maksudnya you select this one. This is actually select. You can select from the set the symmetry. This means you select the faces are listed in the symmetry down here. Okay, this is the part. This is the part. This means for the front, so you must pick stator, you must pick amateur, coil, top and bottom. So you must pick rotor, and also you must pick And then go to the back of the design. So again, let's say this is the back, and then you must pick again, select setter, amateur coil, top one, and then PM, rotor, PM, and then the bottom permanent, the bottom amateur slot. Right. So only for this step number 2. It's quite confusing, and now I have explained to you on how to set the symmetry boundary of the 3D model. So kita nak select lah part ni, part depan ni, dan juga part dekat belakang ni kita select. Okay, bila kita select, kita extrude, dia akan jadi 3D lah. Kalau kita, maksudnya kita select yang ini, select yang belakang, kita extrude, dia akan jadi 3D. From face depan ni, front face, ke back face ataupun bottom kat belakang ni. So dia akan extrude jadi 3D macam ni. Okay. The rest tak ada masalah lah. The rest no problem. So it is clearly stated. You can see clearly stated over here on how to do the setting, the condition setting, etc., etc. And then answer the question number 1, number 2, blah 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 blah. And then okay, ni what happen if you increase the number of turn from 10 to 20. And then okay, ni yang ni lah. So this is the most important part. Kalau you confuse lah, amateur coil is set in reverse polarity. So which one you should do? For question number 4, how to do question number 4? So again back to our teruknya lukisan ni. Mana yang kemas sikit? Okay, ni kemas sikit. So remember amateur coil yang ini tadi ada cross kan. This is cross into pitch. This is out of pitch. Outward, out of pitch. Now you change the reverse, you reverse the polarity. So reverse the polarity, question number 4. Okay, let's see here. Okay. Reverse polarity of the amateur coil. Okay. So instead of cross, now you have dot. So you have dot over here. So this is we have cross. Reverse, all reverse. Instead of dot. Here we have, and then analyze what will happen to the amateur flux linkage. Mana? Dia suruh tengok apa? So characteristic PM flux in one of the amateur. One of the amateur. Not all. One. One means one set lah. One set, not all. Sorry. Not all. This part will remain. Which part? This part, let's say. Okay. This part will remain. Okay, remain. So yang ini yuk reverse. Reverse. Alright. Okay, so graph number 2 comes from step number 9. Yes, step number 9 we would produce graph number 2. This means you are doing the comparison between the 2D model and also the 3D model in terms of the finding of the graph. Okay, so apa yang berlaku lah? So what happened between these two graphs? Suppose we got the similar graph lah, similar curve of graph, and then what happened to the amplitude? Which one is much better? The 3D ataupun the 2D analysis? Okay. Dia sebenarnya sama je, spek dia sama, the parameter sama, the condition setting sama, the material also sama, tetapi 2D dan juga 3D analysis. So apa yang berlaku pada graph in terms of the flux linkage or magnetic flux. And then observe the clogging torque. Clogging torque tadi boleh lihat pada graph yang di atas. Mana tadi? Ada 2D kat sini tadi kan? Ni. Ini kata ni torque ni lah. So klik pada torque ni. Okay. Klik, and then nanti akan show. Klik show tu lah. Nampaklah graph tu. So in this particular experiment sheet, of course we don't show you the graph lah. If you show the graph, and then easy for you kan to crop and get the result. So the result is mystery, is in puzzle. Okay. So you must get the correct result. Discuss among the group members. or intergroup, discuss which result is correct one. Okay. Then this is a group number. Sorry, graph number. To stop graph number 3. So far ada soalan? Kalau tak ada soalan, nanti you all pergi ke apa benda tu? Pergi ke outer. Kat situ ada folder untuk submit report. Okay, ada folder untuk submit report. Satu group, satu report. E-copy. Attendance, make sure you fill out attendance for today's session.
Baik, sir.
Alright. Semua clear? Clear.
Dah semua
I will
clear, sir.
count. I will count in 3. Countdown lah in 3 before we end the session. 3, 2, 1. Okay, all good. Thank you very much for attending our session this morning. So good luck and all the best. Hopefully you start downloading the JMAC and start doing all the procedure, the experiment, and come out with a good result. So anything happen, any problem, you can always text me and ask me how. Okay. Terima kasih sekali lagi. Last word tak ada. Selamat Hari Raya. Tak sure jatuh raya hari Jumaat atau hari Sabtu. Tapi tahun ni
Selamat
wife saya
berbuka,
tak
sir.
cuti lah. Wife saya tak cuti. Tak cuti maksudnya raya yang public holiday sajalah. So public holiday hopefully jatuh hari Jumaat. Saja. Okay, thank you very much sekali lagi. Have a nice day. Take care everyone. Assalamualaikum.
Welcome, sir.
Bye-bye.
Selamat Raya, sir.
Selamat Raya. Okay, bye-bye.
Selamat berbuka semua.